Hello, my name is Darren Thomas. I am the Director of Educational Research Techniques. In this video, we're going to take a look at linear and angular speed as it relates to circles. So let's go ahead and get started. So I need you to imagine for a second that, of course, we have a circle. And so let me go ahead and make this circle for you. So here's our circle. Oh, wrong color, sorry. Alright, there's our circle. And now, the thing is that when an object travels around a circle, so just to give you an idea, when it travels around a circle like this, of course it's going to be on the circle, not above it like this, or, there are two types of speed involved here. And those are linear speed and angular speed. Now when we're talking about linear speed, we're talking about speed along a straight path. Now, of course, the path isn't quite straight, but it is what it is, and it's like it's moving along. It's a displacement given over time. So, linear is like linear speed is like the speed like going in a straight line, but it's not quite a straight line. But just be patient with me on this one. And so, what you need to know in order to figure this out is you need to know several things. And so the typical formula that you will see is going to be V, which is going to be the linear speed, equals S over T. T equals time. We'll just write it out. S, it kind of has two things that I've seen in textbooks. Sometimes it's called the arc length. So we'll call it the arc length. And other times it's called the displacement. Again, I'm sure there's a reason behind this. Don't get stuck on the terms here. And so what you need to know are several things. Now, in order to have success with this, you must know, what the arc length is. And so the arc length is like the distance. Now, in this particular situation, the arc length and the circumference are the same thing because you need to know the distance all the way around. In other words, the arc length for the whole thing, not just a sector, but the whole thing. So that's also the circumference. And so the formula for that, which I'm sure you're familiar with, is 2 pi r. That's what it is. Now, in this example that I have right here, our radius is going to be 10, which means that our arc length, or our displacement, if you will, is going to be 20 pi. Because let me just write it out for you. It's going to be 2 times pi times 10, and that's going to simplify to 20 pi. Now, we need to know the time. And so in this example, what's going to happen is this. Our whoever's traveling on our circle here, they travel the entire distance in 1 second. So we're going to keep this very, very simple. So it takes 1 second for it to spin all the way around. That means that if we want to find out our linear speed, it's going to be as follows. It's going to be V equals, we know what our S is, our length or our displacement, if you will, is going to be 20 pi, and that's going to be over 1 second. Which means if we want to simplify this, it would be, again, pretty much the same thing. 20 pi, we can call it inches or whatever unit we want, seconds, like that. So that would be the linear speed in this particular example when we have a radius of 10 and we are moving around this entire distance once in a second. Now, if I change my time here, of course I'll get different values, but I picked something very simple on purpose. Now, let's talk a little bit about angular speed. Angular speed is the rotation time per rotation per unit of time. And so what is happening is that with this, we have the following. So W is going to be your angular speed. Oh, let me draw my circle again. Let me do that first. So W is going to be like this. Oops, I always do that. So W, because our equation is going to be W equals theta over T. So W is going to be your actual angular speed. Theta, of course, is your angle, your degree, angle in degrees, and this is going to be time right here. Now, let's do a simple example here. We're back to our circle here, our guy right here. And for this particular instance, we don't necessarily need to know the radius. We need to know, how many degrees. So we don't even really need the picture. So let's just say that our circle here, the rotation is 360 degrees per second. So in other words, it's the whole circle. So kind of, you don't need it. So we rotate 360 degrees in 2 seconds. That's kind of what's happening there. So our theta is going to be 360 degrees. Our time is going to be 2 seconds. And so our W, if you will, this is all equals W. Our W is going to equal 180 degrees per second. That's what's happening here. This is not that complicated, but you can see here. So in other words, we rotate 180 degrees in a second. That is like the angular speed. Now let me show you a connection between this and the arc length. Now, here's what we know. We know the following. We're going to start with angular speed, We know that W equals theta over t. Now, here's the thing. If I multiply both sides by t, multiply by t, I get Wt equals theta. All right? Now, when else do we use theta? Now, that means that if S, remember when we calculate arc length, so arc length, also known as S, that was calculated by, let's see here, radius times theta. But now we know what theta is. Theta is the angular speed times time. So that means that arc length, or S, arc length, also known as S, can be known as RWT. So there's a connection between calculating the arc length and determining the angular speed. But wait, there's more. So let me go ahead and draw a little line here. Now, if we know the linear speed is Vs over t, and we know that S equals this right here, so V equals RWT over RWT over t, and you know what that means. These cancel out right here, and so that means that the linear speed also equals the radius here times the angular speed, like so. And so you can see that there's a clear relationship between knowing the arc length and being able to calculate these various components here. So if that was confusing, trust me, it's very abstract even for myself, and I hope I made that as clear as possible. But we're just trying to point out how these things are related. The arc length, the angular speed, the linear speed, there's a connection between them and how they work. So let me kind of recap what we talked about today, and then we will close out this video. So in this particular video, let me go back here to my first slide here. We talked about angular speed and linear speed. So with linear speed, it's kind of the distance in a straight path going around something. All right. It's the distance of a straight path. So the formula is V equals S over T, where S is the arc length, also sometimes called the displacement over time. And so you have to find out your arc length, which again is related to the circle here. We're treating it as a straight line. And so it's 2 pi times r. Once you have that, you can do the additional steps to finish off the calculation, as you can see right here. The next one that we talked about was angular speed, and that's like the rotation around the point, if you will. And so you got to know your degrees, your theta over time. That'll give you your angular speed. And so in this example, we got 180 degrees per second. And again, the unit time could be seconds, days, weeks, years, whatever. But for our example, it was just seconds. Now, on this slide, even though it was very abstract and kind of hard to understand, we gave you some insight into how to see the connection between arc length and angular speed and linear speed. And so what we learned was this, is that the formula for finding the angular speed helps you to figure out what theta is. Theta is basically the angular speed times time. And then when you know theta, basically you can figure out the arc length by doing r, the radius, times the angular speed times time. These things like that are all working together. That's what we're learning here. And so then we also learned about this for what do you call it? Linear speed. Linear speed is displacement over time. But see, here's the thing: if arc length is RWT or if displacement is RWT, you can put that on top here, and then it simplifies to radius times angular speed will give you the linear speed. And so that's why they're connected like that. So I hope that this video was useful for you and it made sense. Again, with the abstract stuff, I hope that you're patient with that and able to grasp it. My name was Darren Thomas. I am the Director of Educational Research Techniques. Take care.